Okay, today we're going to be talking about all the basic characteristics again of sine, cosine, and tangent, and then how the graphs would look with different transformations applied to them. So the first graph I'm going to be looking at is a graph of sine theta or sine x. So y equals sine x. The graph of sine, the first thing to keep in mind is that it always starts at its midline. Now, without any shifts, its midline is at 0, 0. And so I start my graph at 0, 0. Our graph of sine takes one loop of the unit circle. So one loop of the unit circle ends at 2 pi. So my graph will end at 2 pi. And I've got to fill in the middle here. The key angles for sine are every pi over 2 angle on our unit circle. So pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and then 4 pi over 2, which is our 2 pi. So sine starts from 0, 0, and then it goes to its crest, or its a value. It goes to its crest, or its a value above the midline. At pi, I go back to my midline. And for 3 pi over 2, that's the bottom of my unit circle. And so the bottom of my unit circle means I've gone down 1. And so this is what one period of sine looks like. Now remember, this can continue forever in either direction. Now what happens as I do different transformations to this graph? The first transformation I'll do on the same picture. Other ones I'll do on a separate. Let's say I multiply the a value and make it be 2. And I move the midline down 1. So the first thing I'm going to identify is these changes. And so my a value is 2. Notice nothing touched my b, nothing touched my x, so my b is 1. And then this value on the outside, that's my k. So my k is -1. Well, on a sine graph, an a of 2 means my amplitude is 2. My b being 1 means nothing happened to my period. And the standard period of both sine and cosine is 2 pi. And k equaling -1 means my midline happens through the horizontal line of y equals -1. So the first thing I'm going to do on my graph is I'm going to sketch the midline for myself so that way I can reference it. So I'm going to go ahead and use a highlighter to show my midline. And so all my distances for my amplitude will be based upon this. So actually I'm going to have to actually erase the old graph because I need to zoom out. So we won't be able to have the original here, but you can already see that there's going to be a move because the original midline was at 0 and my new one is moved down 1. So let me go ahead and erase some of this so I can adjust my window. All right, now I have enough room to graph. All right, so as I was saying, the midline is through -1. This is an imaginary line. It's what is in the center of my crest and troughs. So sine always starts at its midline. So sine is going to start on this midline. So at the angle 0, it will be on the midline. My b didn't change. That means my key angles didn't change. My key angles are still going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. So those do not change right now. And so remember that sine usually goes to its crest. And so my a is 2. That means I'm going to go, at pi over 2, I'm going to go 1, 2 above my midline. I'm going to go 1, 2 above my midline. At pi, I'm going to come back to my midline. So at 0, pi, at all the pi values for sine, I will be at my midline. And so that creates the crest of my wave. At 3 pi over 2, I now have to go below the midline because I'm at the bottom of my unit circle. So I have to go 1, 2 squares below my midline. So I'm not going to -2, I'm going 2 below the midline. And then my period ends at 2 pi. And so as we're looking at this graph, notice that, oops, so here's my boundaries. It's between 0 and 2 pi. My 1 and -3 are actually creating my range. So my graph goes as low as -3 and as high as 1 because that's 2 above and 2 below the midline. And each of these key angles happen by dividing up my graph. So if I go right in the middle of my period, okay, I'm at pi. If I go in the middle of that, if I go in the middle of those sets, that creates my next key angle. If I go in the middle of these two, that creates my next key angle. So I get 1, 2, 3, 4 sections. So it's always, all these key angles are always going to happen 1/4 of my period. Let's look at a different equation. Let's look at y equals cosine of 1/2 theta plus 1. The first thing I identify again is my a value. So my a value in this situation is 1. That means my amplitude will be 1. So I will go 1 above my midline and 1 below my midline. My b value, remember in the generic form we gave you, it was 1 over b theta. So my b value is actually 2, which means I need to multiply my period by 2. So my base period for cosine is 2 pi, but now I'm going to multiply it by 2 to get 4 pi. And then this graph has a k value of 1, which means my midline is going to happen through y equals 1. All right, so in green, I'm going to give you the parent graph of cosine. Cosine starts at its amplitude above the midline. So the basic graph of cosine starts at the amplitude above the midline. At pi over 2, it reaches the midline. At pi, it's the amplitude below. 3 pi over 2, we're at the midline. And at 2 pi, we finish our graph. Well, one period of it. And I make my nice wave. Okay, so sine started at the midline. Cosine starts at the amplitude above the midline. Now let's see what this new graph we have is going to be. The first thing is my midline is now through 1. So I'm going to draw that in. My period's going to go all the way over to 4 pi. So I'm going to have to finish my graph by the time I reach 4 pi over here. I know my graph can go as high as, let's see, 1 above my midline. So 1 above my midline, it can go as high as 2. It can go 1 below my midline. So it can go as low as 0. So my graph is going to start at my a above my midline. But now where are these key angles going to happen? So you can either divide your picture into fourths, or we can go back to those key angles we talked about. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we can multiply each of these angles by our b value. So if I multiply them by b, I will see where my new values are. So 0 times 2 is still 0. So we're still starting at a above the midline. Pi over 2 times 2, the 2's cancel, I'm left with pi. So if I start at the crest at pi, I'm going to have to be at my midline. So that angle relates to that one relates to that one. Pi times 2 is now 2 pi. So pi now moves to 2 pi, but it's 1 below. So 1 below the midline. All right, and then 3 pi over 2 becomes 3 pi. So at 3 pi, I'm at my midline. And then at 2 pi, that becomes my full period of 4 pi. So you can see it's been really stretched out. It's being stretched horizontally. But I still try to make it as smooth of a wave as possible. All right. And again, this is just a brief review. So the next one we're going to look at is tangent. My basic graph of tangent has vertical asymptotes through pi over 2 and negative pi over 2, because these are the values on the unit circle that tangent is undefined. These are the values that tangent is undefined on the unit circle. When we have an undefined portion of a graph, we get a vertical asymptote. So we have vertical asymptotes through plus or minus pi over 2. Key points on the graph are negative pi over 4, comma, negative 1, because the unit circle value for tangent at negative pi over 4 is negative 1. The unit circle value of tangent of 0 is 0. And pi over 4 is 1. So these happen at 0, 0, pi over 4, 1, negative pi over 4, 1. So remember when we do transformations that A values and K values are outside the function. They're on the outside, so they affect our outputs. So these values are going to be affected by A and K. These three values, these negative 1, 0, and 1, will be affected by A and K. Your inputs are affected by anything that goes inside the function. And so remember, B and H go inside the function. In our situation, we will only be worried about B. So you will only multiply these angles by B. Over here, you will multiply by A and add K. So let's look at an example. Let's go with y equals 1/2 tangent of x minus 1. Okay, so the first thing I've got to look at is my A, B, and K. A is not my amplitude. A is not my amplitude. Tangent does not have an amplitude. So A is just 1/2. So that's just going to affect my key angle outputs. And so the basic period of tangent is pi. So A is 1/2. And B here is 1. That means my period hasn't changed. My period is still pi. I do have a midline shift, though, with K being negative 1. That's my midline, my middle. So I know I'm going to need a middle line through negative 1 here. My vertical asymptotes are plus or minus pi over 2. And I usually multiply them by the B value. But in this case, B is 1, which means my midlines are going to remain, or my vertical asymptotes will remain the same. So my vertical asymptotes are not different because the B is 1. My key angles, 0 is pretty straightforward unless there's a horizontal shift. But my two most important key angles are usually the pi over 4s. And again, you would multiply them by B. But in this situation, our B is 1. So the angle will remain the same. Now, when I go to pi over 4, Okay, at pi over 4, I normally go to A. And at negative pi over 4, I normally go to negative A. That's really A above the midline and A below the midline. So at pi over 4, I'm going to go A above. So I'm going to go 1/2 above. At negative A, I'm going to go A below. So I'm going to go 1/2 below. And at 0, I'm on my midline. So I end up with a wider graph. Well, really a shorter graph that's been moved down. And so hopefully some of those basic transformations help you better remember how to do these going forward.